I am Romet Badis for LivePhysics and I am doing the review for Physics 2. Question number 1. On a certain day in New Australia, the daytime temperature was 16 degrees and the nighttime temperature was 4 degrees. What is the temperature difference between the day and night in Kelvin? So we'll first find the temperature difference in Celsius. 4 degrees, that's 12 degrees Celsius. So the key concept that they are trying to test here is that 1 degree in Celsius is equal to 1 degree in Kelvin. That's just a defined thing. So the answer is simply 12 Kelvin. Question number 2. As shown in the figure A, the glass Q sticks inside the glass P. Which of the following strategies is suitable to separate the two glasses easily? So they have given us a diagram that looks like this. So there are two glasses that are just stuck inside of each other. They are asking what should we do to separate them. So they have given us 5 answers where they have filled this part with 1 temperature of water and the inside of this cup with another temperature of water. So in the first answer they have given hot water for here and hot water for here as well. And in the second answer it's cold water here and hot water here. And in the third answer it's hot water here and cold water here. And in the fourth answer it's both cold water. So what happens to an object when it is heated? It's called thermal expansion, right? An object increases in its dimensions. So in order to free these two cups, what should we do? We should either decrease the size of the cup inside this or increase the size of the cup outside, ne? So in order for that to happen, like I said, when heated it expands. When an object is cooled, it contracts, reduces in dimensions. So to expand this, we need this to be hot water and the inside of this to be filled with cold water. So the answer is 2. Question number 3. Under normal atmospheric pressure, a pure block of ice at temperature minus 10 degrees Celsius was heated at a uniform rate until it was turned into liquid water, and then for some time after the water started to boil. Which of the graphs correctly indicate the variation of the temperature of the system with time? So they are asking for a temperature versus time diagram. So initially the block of ice was at negative 10 degrees Celsius. So it's at the solid state. If we draw the axis like this, the temperature versus time. So at the 0 mark, it was at minus 10. Yeah. So as it was heated, what happens? It slowly increases in temperature. And then what happens when the ice block reaches 0 degrees? It transitions into a different state, right? It turns into the liquid state. And here, instead of increasing in temperature when the heat is provided, it simply uses it to change the state. We know this as the latent heat of fusion. So it will continue to absorb heat while staying at 0 degrees, and then once all of it is turned into water, it will heat up. And in the question they're saying that the water started to boil. So in the graph we should also include a point where the water may transitions into the gas state. So here it is boiling. So the correct graph for this is 2. Yeah, answer number 2. Question number 4. Heat is transmitted from the sun to earth by answer 1 radiation, answer 2 conduction, 3 convection, 4 radiation and convection. So this is just a theory question. So the sun gives us energy through radiation. It shoots electromagnetic radiation, also known as photons. Since there is a vacuum between the sun and the earth, the other forms of heat transmission cannot happen. Conduction requires some sort of material medium. Convection requires either a gas or a liquid. Since nothing is present between the sun and the earth, it's obviously got to be radiation. So the answer is 1. So question number 5. Consider the following statements about heat transfer. A. Sea breeze and land breeze occur due to conduction. B. Heat reaches the earth from the sun by radiation. C. When a metal spoon is put into a hot cup of tea, it is heated by convection. Let's go through each statement one by one. So statement A. Sea breeze and land breeze occur due to conduction. This is obviously false, right? It occurs due to convection. So if we go over how sea breeze and land breeze occurs, if this is the land and this is the sea, during the day both the sea and the land heats up, right? But due to the lower heat capacity of the land, it increases in temperature in a lesser time than the sea. So the land is considerably hotter than the sea. So convection currents occur. So air particles near the surface of the land gets heated up and they move upwards due to the lower density, and then colder air particles near the sea move in to replace those particles, and that's how sea breeze occurs. So yeah, this is basically a convection current, right? Hot air moves up, cold air comes down to replace them. That's the definition of convection. But at night, again due to the difference in their heat capacities, the land loses its heat much quicker than the sea. So at night, the sea is warmer than the land, and the opposite happens here. So air particles here gets heated up, and when they get heated up, their density decreases and they move upwards, and colder air from the land moves into the sea to replace them. Yeah, that's the basic definition of sea breeze and land breeze. So statement A is false. B. Heat reaches the earth from the sun by radiation. So in question number 4, this was tested. It is true. Heat reaches the earth from the sun by radiation. Statement C. When a metal spoon is put into a hot cup of tea, it is heated by convection. So here you could argue that maybe the hot cup of tea has convection currents in it because the cold spoon causes a current in it. But they are asking about the metal spoon, right? So it's a solid object, and when it is dipped in a hot cup of tea, this is the spoon, the water around it is hotter than the spoon, so it simply heats up due to conduction. So statement C is also incorrect. So the answer is only B. Yeah, let's move on to Newton's laws of motion. Question number 6. the gravitational acceleration on the moon is 1/6 that of the Earth. If the gravitational acceleration on the Earth is 10 meters per second squared, what would be the weight of an astronaut of mass 60 kilogram on the moon? So yeah, they are asking for the weight of the astronaut on the moon. So yeah, what's the weight of the astronaut on Earth? Weight is simply the mass into gravitational acceleration, right? So his mass was 60 kilograms, and the gravitational acceleration they've given as 10 meters per second squared. So that's 600 Newton, right? So we can use the same principle that we use for the Earth on the moon. So they've given that the gravitational acceleration of the moon is 1/6 of the gravitational acceleration on the Earth. So we can simply say that the weight is 60 into the gravitational acceleration of the moon, which is 1/6 of 10, 6 to 60, 10, 100 newtons. So the answer is 2. No, sorry, answer is 3. Question number 7. The SI unit of force in fundamental units is. So what is the SI unit of force? Not in the fundamental unit. What is the derived unit for it? It's Newton, right? So if you can remember it, 1 Newton, so Newton can be written as kilograms meters per second squared. But if you cannot remember this, you can simply remember the equation F equal ma, right? For an equation, the units on both sides should be equal, ne? So since force is given in newtons, this side also should simplify into newtons, right? So here the unit for mass is kilogram. SI unit is kilogram, not grams. And the unit for acceleration is meters per second squared. So simply they multiply to give kilogram meters per second squared. So the answer is 1. Question number 8. The acceleration due to gravity on the Earth's surface is 10 meters per second squared. The acceleration due to gravity on the surface of the moon is 1/6 of the acceleration due to gravity on Earth. If the weight of a man on Earth is 600, how much is the weight on the moon? They have tested this question in 2020 O levels, and that's the same idea as the question in 2018. So they have, instead of giving the mass, they have directly given us the weight here. So the answer is the same. It's 100 newtons. Answer number 2. The unit of momentum is. Question number 9. The unit of momentum is. So we can straight away say that is kilograms meters per second, if you can remember it. But if you cannot, you can remember the equation momentum is equal to mass into velocity, right? The same principle as the question I did before, where I used F equal ma. Same thing here. Since this is momentum, the units on here should simplify to momentum. So for mass, it's kilograms. For velocity, it's meters per second. The answer is kilogram meters per second. Answer number 2. Oh no, answer number 1. 10. What is the advantage of using the handle fixed to a door in the occasion of opening and closing it? 1. Adequacy of applying a low moment of force, being able to execute a great rotation reduction, being able to execute a greater rotation reduction. 3. Adequacy of applying a smaller force, reduction of the amount of work done. So let's see, why do we grab the handle from the end? Yeah. Yeah. So let's say that the door can be opened. Say this is a door. I'm sure you've done this question before. Which point along here, if this is the axis that it spins on, if we apply a force, the same force here, here and here, no, not the same force. If we try to rotate the door around by applying force here, here and here, which one would be the easiest? It's obviously here, right? Since yeah, the object rotates due to the moment applied to it, right? And we can say that the moment is equal to the distance into the force applied. So we can apply a smaller force if we use a greater distance away from the axis of rotation, right? So the answer is 3. Adequacy of applying a smaller force. Question number 11. Which of the following phenomena agrees most with Newton's third law of motion? Answer number 1. A ball falling down from a higher level bouncing after touching the ground. 2. The velocity of a fruit falling from a tree reaching the maximum value when it comes closer to the ground. 3. Flinging of passengers forward when the brakes are suddenly applied to a running bus. 4. Changing the direction of a moving football by kicking it. So the answer is 1, but we'll check each answer one by one. So yeah, let's first check answer number 2. The velocity of a fruit falling from a tree reaches maximum value when it comes closer to the ground. So what is the law that is closest to this phenomenon? I would say that it is F equal ma, right? Since the fruit accelerates due to an acceleration, obviously. So yeah, the changing in velocity is done due to the acceleration, right? You guys know this equation as the velocity is equal to the acceleration times the time. But in A-levels you learn more complex equations, right? We like the velocity is equal to the initial velocity plus the acceleration in time and stuff like that. But so from this is related to the acceleration, and from that we can find the velocity. So the law that is closest to this second answer is F equal ma. For answer number 3, flinging of passengers forward when brakes are suddenly applied in a running bus. This is closest to the first law, right? The law of inertia. What does inertia say? An object at rest will remain at rest unless the force acts on it, and objects moving at constant velocities will continue to move in constant velocities unless the force acts on it. So when the brakes are suddenly applied in a bus, so when you're traveling in a bus, you have the same velocity as the bus, right? So relative to you, the bus does not move. But when the brakes are applied, you keep moving in the same velocity. That's why you get flung forward. That's closest to the law of inertia, Newton's first law. So let's check answer number 4. Changing the direction of a moving football by kicking it. So that's again F equal ma. Oh, it's not a Newton's law, but you can say that it is the yeah when the football approaches the foot and the guy kicks it, the ball changes direction and the speed, right? So it changes in velocity. So the law that is closest to this is simply the change in momentum is equal to mass into velocity. Sorry. The the change in momentum. Here, since the mass stays the same, simply the change in velocity. The momentum changes, and if an impulse is applied, the momentum of the ball changes, therefore the velocity changes. So the answer number 1, a ball falling down from a higher level bouncing after touching the ground, that's the closest one to Newton's third law. Let's see why. So the ball falls down and hits the ground, right? The ball exerts a force on the ground, and according to Newton's third law, the floor also exerts a force on the ball. So according to Newton's law, what does Newton's third law say? Every action has an equal and opposite reaction. So this same force that the ball applies on the floor is applied on the ball, so it bounces back. So answer number 1. Let's move on to friction. Question number 12. The limiting frictional force between two objects with rough surfaces in contact depend on. This is a direct theory question. Answer number 1. The area of the contact surfaces. Wrong. The normal reaction and the nature of the contact surfaces. This one is actually correct. Answer number 3. The nature of the contact surfaces and the area of the contact surfaces. Like I said, area does not matter. Answer number 4. The area of the contact surfaces. Wrong. And the normal reaction. Correct. But answer 4 is wrong. So how did they teach you this? They simply took a cuboid with different dimensions on each side, right? And then you placed it on a rough surface. You took a rough cuboid and placed it on a rough surface, and then tried to apply the same force, and the block begins to move with the same force no matter what orientation you put it in, right? So the area does not matter. If you put it in the other direction, on the smaller area side, you still need to apply the same force to get it to move. So it only depends on the normal reaction here. The normal reaction here is simply since this object is in equilibrium, the only forces that act are the weight and the normal reaction on this, right? And that exerts a normal reaction on the floor. This is on the floor, but since this is in equilibrium, the normal reaction is equal to the weight. Since weight does not change, the frictional force did not change. So the frictional force depends only on the contact surfaces. If the contact surfaces are smooth, there is no friction. So friction obviously depends on the nature of the contact surfaces. So the answer is 2, the normal reaction and the nature of the contact surfaces. Let's move on to turning effect of a force. What is the unit of moment of force? Again, if you cannot remember the units, the moment of a force, the units are Newton meters. But if you can't remember that, let's say moment of force is simply the distance from the axis of rotation and the magnitude of the force. So if this side has the units of moment of a force, the discharge should simplify to the same unit. So the units of length is meters, of force is Newton. So Newton meters. Answer number 3. Question number 14. In which of the following instances does a couple of forces act? When a door is opened by pushing, when a nail is unscrewed by a screwdriver, when the rope is pulled in opposite directions by two groups in a concrete. 4. When two persons are pushing a box in the same direction which is kept on the floor. So what does a couple of forces means? Yeah, here couple of forces means that around an axis of rotation the same force acts at a similar distance but in the opposite direction, right? This is a couple of force. So the only answer that provides something like this is when you use a screwdriver, right? So you twist it with your fingers where you apply a couple of force. Yeah, the answer is 2. Question number 15. The figure shows a couple of forces is applied to rotate a wheel of 0.4 meter radius. How much is the moment of this couple? So really easy question. The diagram they have given is this hexagon circle. The radius of it is 0.4 meters, and they apply a couple where one force is 5 Newton. So by definition, so here again this is 4 meters because it's a circle and the radius is the same. By definition, the magnitude of a couple is the is defined as the perpendicular distance between the two forces and the magnitude of one force. So here the distance between these two forces are 0.8 and the magnitude of one force is 5 Newton, right? Yeah, so the answer is this. They have not simplified this in the answers, so the answer is 2. 5 into 0.8 Newton meters. Question number 16. The diagram shows a cross-section of a cylindrical concrete ring kept on a flight of steps, indicated as A, B, C, D, are 4 points at which force can be applied by a man to roll it to the upper level. What is the point at which force can be applied on the cylinder in a suitable direction to roll it up with the lowest force? So again they are asking where you can apply the lowest force to lift it. So let me draw a diagram here. So there's a wheel here, magnificent circle, and yeah, it's on a surface and it's on a block like this. They're trying to move it up the block. They have given us the points A, B, C and D. So here they have given both A and B as an answer because the perpendicular distance, so the distance from B to the point of rotation here and from A to the point of rotation is approximately the same in the diagram they have given us. So let's go with the theory here. To provide the least force, like I said earlier, to get the same moment of inertia, you can lower the force and increase the distance from the point of rotation to the force, right? So you need to find the point that is furthest from this point of rotation. So in the diagram they have given us both A and B have similar distances. So yeah, answer is both 1 and 2. That's it for physics 2. Good luck with your O-levels. Thank you.